All right. So today we shall be learning about radicals. This is basically going to be everything related to radicals in, uh, in one video. So let's get right into it. So let's first recall what a radical is. So say we had a radical written like this. So something like that. Um, this is called the radical symbol, and this number right here is called the radicand, and that is the index. This is the coefficient, much like the coefficient in front of a variable. Coefficient. So, how do we use radicals? When manipulating radicals algebraically, there is really one simple rule we must know. So, I don't need that there. So, here's what we do. So, if the square root of the product of two numbers, let's make this one a different, let's make the b a different color. Then this is going to be equal to the square root of a times the square root of b. Now, let's do a quick example, shall we? So, say you had something like the square root of 15. How would we rewrite this? Well, that would be the square root. 15 is the same as 3 times 5. And so in this case, our a would be 3, b would be 5, and therefore that would be 3 times square root of 5. Now, how do we, well, okay, see, right now this is not really useful, right? I mean, 15 is not a perfect square. Therefore, the square root wouldn't be integer, or it wouldn't be a the square root wouldn't be a whole number, and same here. So these are this. So in fact, we want to use this rule to simplify radicals. Now, what do I mean by that? What do I mean by simplify? Well, essentially, Say it had something like the square root of let's see, 32. How about that? And if we were to simplify this radical, we want to find some two numbers. Want to find numbers within that are a factor of 32, and also one of the factors is a perfect square. So therefore, we can, let's just say it's n squared m. So therefore, n squared and m are both factors. So let's go ahead and do that. Let's draw our factor tree here, and we know that 32 is equal to 8 times 4. Aha! Well, we see that 4 is a perfect square. But that's not the only perfect square. There's also 2 and 4. Ah, this makes 16, which is also a perfect square. And we always want to find the largest perfect square. So in fact, n squared in here is the largest perfect square, and it's always good to factor them into factor the radicand into prime factors, so you can find the largest perfect square. So there. So for this particular example, it will be the square root of. We know that 16 is the perfect square. So 16 times 2. Therefore, we can rewrite it as this. Now, we can see that this is in the form of the square root of a times b, right? So therefore, we can just simplify that. This will be, we can rewrite this as square root of 16 over square root of 2. But we already know that 16 is a perfect square. So therefore, square root of 16 is actually 4. And that's how you would simplify radicals. And whatever is left inside of the radicand will not be a perfect square. So things that cannot be rewritten as the product of a perfect square and another number is called a surd. So this is called a surd because square root of 2 cannot be factored into the product of a perfect square with another number. Okay, so let's do another example. So let's say we got square root of Square root of 18. Well, drawing our factor tree, we know that 18 is 2 times 9. But we already know that 9 is a perfect square, and 2 is not a square. Therefore, we rewrite this as square root of 9 times square root of 2. That would be square root of 9 times square root of 2. That would just be 3 square root of 2. So pretty straightforward. Now notice we're only working with square roots here, but we can also generalize this, right? So say you have something like the cube root of let's say 16. Well, we want to look for a perfect cube, which is a number that has two of the same numbers multiplied together to get that number. So drawing our factor tree. So we can break this up into 2 and 8. But 8 is a perfect cube because 8 is 2 times 2 times 2, which is 2 cubed. So that would be cube root of 8 times 2. Rewrite this as cube root of 8 times the cube root of 2. That would be 2 cube root of 2. So it's the same concept.